All right, Algebra 1B students, welcome to part 1 of lesson 11.5. I'm solving rational equations. We've been talking in chapter 11 about rational expressions, fractions that involve polynomials, x's, x squareds, and things of that nature. And today, we are going to look at rational equations, which is equations meaning equal signs that involve rational expressions. So it'll be rational expressions that equal other rational expressions. Okay? The first step when we are going to solve a rational equation is to multiply each side of the equation by the least common denominator. Our goal with that is to eliminate all of our fractions. We don't want any fractions involved, so we're going to multiply by the least common denominator to get rid of all of those fractions. And here's what that's going to look like. When I'm asked to find the solution of 5 over 12 minus 1 over 2x equals 1 over 3x, my first step is find the least common denominator. Well, I know that 2 and 3 can easily be multiplied to get 12. If I times this by 6 and I times this by 4, I can easily multiply a 4 onto the 12 to get an x. So my least common denominator here, if I bring these all together, is a 12x. I can turn all of those denominators very easily into 12x. So then I will multiply that entire equation, 5 over 12 minus 1 over 2x equals 1 over 3x. I'll multiply all of that by a 12x 1. Okay. So I'm going to distribute the 12x, which is my least common denominator, to each piece here. If I go there, this becomes 60x over 12 minus 12x over 2x equals 12x over 3x. And now I can do a lot of simplifying, a lot of canceling out. In this first piece, 60x over 12, the 60 and the 12 can cancel out. It'll be a 1 and a 5, 5 over 1. So this is 5x. The 12x and the 2x can cancel the x pieces, and the 2 goes away, and the 12 can become a 6. So that's minus 6, and there's nothing else left. And then the 12x and the 3x, similarly, the x's can go away, the 3 goes away, and the 12 can become 4. It's 4. Now, I have gotten rid of all of my fractions right here. There are no more fractions in this equation, which is exactly what I want. That was the whole point of multiplying by that least common denominator, was to get rid of all of our fractions. So I can simply now add 6 to both sides, and I will end up at 5x being equal to 10. And then, of course, x is equal to 2. Now, x is equal to 2. That's the solution I found for that rational equation. But it is important to plug that back into your equation and make sure that it works. I'm going to take that x equals 2 and I'm going to put it right back up into there and there, back into my original equation. Okay, so I'm taking this and putting it back up in there. And my equation will then say 5 over 12 minus 1 over 4 equal to 1 over 6. I do 2 times 2 here, and I do 2 times 3 there. So 5 over 12 minus 1 over 4, if I get a common denominator, this is 3 twelfths. By timing by 3 on top and bottom. So 5 twelfths minus 3 twelfths is equal to 2 twelfths, which if I simplify down is equal to 1/6. So yes, that works very well. Okay? It is important to check your solutions. They will not always work. Sometimes you have extraneous solutions that don't work. Okay? Now it's your turn. I would like you to try letter A. I've got it, number 1 right here. I would like you to find the solution of this equation here. 1 over 3 plus 3 over x equals 2 over x. multiply by the least common denominator, get rid of all your fractions, and then you can come back and I will show you what we should get. All right, when we bust out our fractions, we should get x plus 9 equals 6. X is equal to a negative 3. Okay? And if you plug that back in, you find, well, that's 1/3 plus 3 divided by negative 3 is negative 1. 2 over negative 3 is negative 2/3. 1/3 minus 1 is negative 2/3. Yes, that works just fine. Okay? The denominator that we should have multiplied by is 3x. We should multiply by 3x. That would be the goal. Not 3x squared. You don't need to, even though two of them do have an x. You can just do 1x because none of those denominators, I should say, have an x squared in them. Okay? All right. Now, the other type of problem that we may see does involve some x squareds. Okay? We might need to factor to solve here eventually. But let's see what this equation gives us. They're asking for the solutions of 1 minus 1 over x equals 12 over x squared. They want to know the solutions for that equation. So again, step 1 is to find the least common denominator. This currently has a denominator of 1, so my three denominators are 1x and x squared. Well, I could turn the 1 into an x squared very easily by multiplying by x squared. I could turn the x into an x squared very easily by multiplying by x. And then the third one already is x squared. So my least common denominator here is x squared. No numbers need to be involved because there really aren't any numbers, just ones, which are very nice to work with. So I'm going to multiply this entire equation by x squared over 1. Distribute that to each of these three pieces here. And let's see what I get. I get x squared over 1 won't change anything. Minus x squared over x is equal to 12x squared over x squared. Okay? And now I can do my canceling. In the front, like I said, the first term, nothing will cancel. I just end up with x squared. When I have x squared over x, I can cancel that x and take away this square. Because remember, x squared is like x times x. You can cancel one of them out and be left with an x. So I have now minus x there, and the denominator went away. Then for 12x squared over x squared, the x squareds can cancel out, and I'm just left with the 12. Just left with the 12. No problem. Okay, now, again, the whole point of me multiplying by x squared was to get rid of all of my fractions. I have now done so right there. And now I'm going to solve that by factoring. Hopefully we remember some things about solving quadratic equations. That's from way back in chapter 9. But the first thing that we need to do here is get all of this equal to 0 because we want to solve for x. When we want to solve a quadratic, we need it to equal 0, so I will take 12 away from both sides and end up with x squared minus x minus 12 equals 0. Okay, now I'm going to look for two numbers that I can put into my factors that multiply to give me negative 12, add up to give me a negative 1x. Well, to multiply to get negative 12, I can do 1 and 12, no. 2 and 6, no. 3 and 4, yes, 3 and 4. And the 4 is the one that should be negative. So then I add up to a negative 1. Okay. So x minus 4 times x plus 3 is equal to 0. And now we should remember our two options here to solve for x. Either x minus 4 is 0, or x plus 3 is 0, meaning x equals 4 or x equals negative 3. Okay? Now here's my two answers. It is very, very important for you to plug those back in and see if they actually do work. So I will do that now. I'll plug those back into my original equation. So for the x equals 4, I will have 1 minus 1/4 equals 12 over 16. Well, 1 minus 1/4 would be 3/4. Is that equal to 12 over 16? Yes, it is. That's good. For the negative 3, I will have 1 minus negative 1/3, because 1 over negative 3 is negative 1/3. That's like adding a positive 1/3, which gives me 4/3. And the other side, my 12 over x squared there, is going to end up being 12 over 9. Is 4/3 equal to 12 over 9? 3 squared is 9. Yes, it is. Okay, so I checked them both. They both work. Wonderful. Great. So I have two answers here, x equals 4 and x equals negative 3. I would like you to try solving letter A right here. Letter A right there. What are the solutions of each equation? This is a 6 over 1. So you should notice that the common denominator here, the least common denominator, is very similar to what it was in our example that we went through together. So pause the video, take a look at letter A, then come on back and I'll show you what we should get. All right. Now, on letter A, when we multiply by y squared, we end up with 5y equals 6 minus 6y squared. Now, if I add everything over to the same side like I need to do, I get 6y squared plus 5y minus 6 equals 0. And this is a box and diamond problem. So we'll be right over here. 6y squared, negative 6. So I need something that multiplies to be negative 36 and adds up to be a positive 5. Those two things would be a positive 9y and a negative 4y. And then when I look at my common factors, greatest common factors here, I will have 2 y's and 3. And I will have here 3 y's and a negative 2. So I get 3y minus 2 times 2y plus 3 equals 0. So I can split that, obviously, into my two options. 3y minus 2 equals 0, in which case y equals 2 divided by 3. Or 2y plus 3 equals 0, in which case y equals negative 3 over 2. There are my two answers. Obviously, we should check and make sure they both work. Otherwise, we may have one that is extraneous. Good news for us is that neither one of those is extraneous. There's my two answers, and we are all set. If you have questions about how to get rid of fractions using the common denominator, please make note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.